I'm checking the endpoints. 6 minus 2 is a what? 40nth, and I get that. I just want to make sure. Does everyone agree? Does that converge or diverge? It diverges. Sorry. Can't put an equal sign. Now, how about the x equals, what was the other endpoint? Let's try x equals negative. Then I'll have the summation of n squared times, now watch what happens here. What's negative 2 minus 2? Negative 4 to the nth. How can I rewrite negative 4 to the nth? A negative 1 to the nth and a 4 to the nth, which will cancel at the bottom. Does that converge? That's a plus or minus infinity, right? Isn't that where that sequence is going? In terms of summing that up, that diverges by test for divergence. Does anyone see that? All these, the last 4 things, when we check the endpoints, diverge by test for divergence. The limit was not equal to 0 of the sequence. That sequence. Hey, so that's our answer. If you want to write, what's another way to write an interval of convergence? Does anyone like to put it in interval notation? Like this? Like I can call this my interval of convergence. My IOC. My interval of convergence. Do you like to put it in interval notation? You absolutely can. When can you, what does it mean if you got to put an equal sign there? You got to do what? Close brackets. But you can leave it like this. So there's my interval of convergence. My radius is what? 4, but I always like to include where it's centered at. Where was this centered? At 2. So you're really talking about those numbers in there. You're the mathematician, the computer scientist, etc. You're going, the numbers that work for this are right there. All these in there work. Not only the integers, all real numbers inside that interval. Hey, so summary on that. The radius was 4, and the interval was negative 2 to 6. Hey, I want to do a couple more of these. You know the ones where you get a funny answer? Let's do one of those. And then I saw one. We should definitely at least do a problem where you at least get one of the endpoints to what? Converge. After this, you might think the endpoints never work. True? Sometimes they do. Juliet.
So if it works out like you plug in the values that you got, like negative 2 and 6, and then they end up converging when you plug them back into the original equation, does the interval of convergence change?
The only thing that changes is that symbol at the end, or the symbols right here. The only thing. And all you would do, if it converged at 6, you'd get to put that.
So it doesn't change the interval?
Will not change the numbers at all.
Oh.
And that's why, Juliet, I want you to think of it as not such a big deal to you. You're like, man, I've got this problem really done. I've done 90, that's what I mean, 98% of it. I'm just checking, because there's so many numbers in here. You're just checking these, what? These extremes at the end to see, can I use those as well? I know, there's some institutions, you go, what? They just want the radius. They're like, hey, don't even worry about checking the intervals. They just want to know what the radius is. Wow, let me check this. So I don't want you to think it's such a, don't let it be such a burden. Hey, cool. The key is getting that radius and where it's centered at. All right, here's the next one. Hey, just a couple more of these. We'll go to the next section. Oh, it's got an x minus 1 in the nth. There's not much here, though. There's no negative 1 in the nth or anything. This started at 0. Sometimes they start at 0. Everyone determine the radius of convergence. What test are we doing? Ratio test. You ready to roll this? Boom, boom, down goes infinity. What's that become? X minus 1 to the n plus 1 all over n plus 1 with a factorial. I don't care how I wrote that. Now what are you putting underneath it? That exact expression, and I'll put the dot and flip it, Dave.
I was just going to ask on the test, are we able to just skip that step?
Yes, yes. There are many people who agree with you. The only thing, 11.8, cool section. You notice? It's like, boy, there's a lot of writing. If I keep writing everything. And if you're a student, Dave, sometimes writing everything makes you make errors.
Right.
And you're able to say, in my brain, I can do 2, 3 things at once. Put this over here, I know how that will simplify, that's fine. You know, I'm gonna put the dot and I'll flip it. What's on top? There's the ace of that. I'm doing this is this part. It's just, when you divide a fraction, you multiply the reciprocal. And limit when it's less than a what? So this is what Dave's talking about. What happens every time when we write this? This becomes what? See, this time I'm going to use my eraser. Has everyone got all that written down? I got it easy, I got the eraser. This means what? X minus 1 to the n times up. So we know it cancels there. These just what? This will go out here. That's about x minus 1. How do you simplify that? Do you remember? I like to go off to the side so everyone's okay with this. How do you simplify n factorial over n plus 1 factorial? Dave was mentioning this also, I believe. That he's saying, you know how that simplifies, don't you? So he can do that in his head. And that's what he means, because he can immediately just, I know how that simplifies. Factorials will be able to cancel. That would be like, just give me an example. That's an n, what would be next? N times n minus 1, keep going lower. What's this? N plus 1, what's 1 lower than n? And what's lower than that? It'll cancel.
Everything but n plus 1.
So everything cancels here. Everything. Except for the. So, catch my error. So I'm saying this right here is equal to n plus 1? It's 1 over n plus 1. See how, when you have factorial over factorial, you can always simplify it, or you can eliminate those factorials. Is everyone okay with that? The book would write this as, hey, that's n factorial over n plus 1 times n factorial. You just can't, that's how they would write it. But I want you to be able to see it. It becomes just 1 over what? N plus 1. So in this right here, simplifies to 1 over n plus 1. Where's this going? Out in the front. That's our, I want it to be our key focal point at the end, right? There it is, sit out in front of the limit, doesn't have an n in it. What do you have here? Multiply that times limit, does n go to infinity of? Just this. So this becomes a very interesting problem. I know you know how to find that limit. I don't even think you have to do L'Hopital's rule. It's just what? 0. See the higher power at the bottom? So, can you help me think about this mathematically? What numbers make this converge? This is now a 0. And this is the first time we've gotten a 0 today. You and I are looking at this math statement. Whoops, I forgot to put that other bar up. This is what we're thinking about with these problems. Determine the radius of convergence. Determine the numbers of x that make it work. Determine the numbers of x that make this thing converge. So I'm trying to think out mathematically what x values make this a true statement. When absolute value of x minus 1 times a 0 is less than 1. This has a very interesting answer when you get a 0 here. Because what's anything times 0? 0. So don't think the opposite. Don't say there's no solution. There are many solutions. Now, can I give you some examples? I'll use 10. If I put a 10 in here, is this a true statement?
Yes.
10 minus 1 is 9. What's 9 times 0? Is that less than 1? Okay, let me just pick another weird number, pi. Pi minus 1, great. It's some weird, funny, irrational number. You multiply 0, you get what? 0. So what are we saying here? If I get a 0 here, every time, 0 times something will always be what? So what the heck's our answer? It's not, it does not exist. It's the complete opposite. Our radius. Aren't we thinking all reals? For x? All real values? So here's our radius. What's the interval? How do you write that in an interval? And we can't check those endpoints, can we? But everyone see that? I want to make sure you know why. Anything times 0 will always be less than 1. Put that in your notes. So if you're wondering why we did this. Any values of x in the entire real number system, you multiply a 0 to it, you're going to get 0, which is what? Less than 1. My worry is, you notice what I'm not writing down right now. You know, if I just wrote this times this is 0, and then you might look at your notes and say, there's no answer. No, there's a bunch of answers. All values of x work. Now that's huge to a programmer. Who the programmers and so you're like, oh my gosh, this thing, I don't have to worry about what x has to be. It can be anything. X can be 1,000,000. And this series converges, right? Do you know what made it did? I think you all noticed. The factorial being in the denominator. That carried a lot of weight to the math part of it. We know about factorials and how rapidly they explode. That's what made this work like this. Cool. I know if it was like 2 to the nth, it would have been a different story. If that was 3 to the nth, it would have been a different story. If it was an n factorial, look how it played out.
So it doesn't matter what the center is for these kinds of problems?
Oh,
Just be any-
what is the center? From negative infinity to positive. Let's pretend that's positive infinity. Let's go way over here, Katie. This is negative infinity. What is the center? What's the middle? What, 0? You could say centered at 0. But we're just thinking, hey, it's all real numbers. They said find the radius. So you know what a radius is? It's infinitely large, is what we're saying. It's infinitely large. You get the whole, it's all real numbers, but that's why we write the answer and that's where it will. All x values work. Right? Oh, I got you. The centered at 1 thing people were saying. Centered at 1. You could write that. But key in on, that's my radius. That's my interval. Because of what? What's making that do that? This. This is actually good. Because I want 0 times anything is less than 1. Any value. Ooh, so that's an interesting one. Okay, one more. And then you're like representing functions of power series. And when you got this down. Alright. And when this is like number 17. This is like number 17. That last one was like number 7. Just trying to make sure I hit pretty much the spectrum of the practice problems I put down. This has, okay, how about a 2 to the n? This has got a, I wanted to give you one that had like a plus in there. So I wanted to give you that. What if it's x plus 2? Amanda, do you remember where the radius, the center would be in that? There, yeah, it's centered at -2. And oh, this had a square root. So I wanted to at least give you one of those as well because I didn't want the square root to bug you. We're determining the values of x that make that series converge. We immediately go to the ratio, so the limits, and it goes to infinity. And watch, I bet you there's people in this room already, you're off to running with this. You're off and running, and you're doing 2 steps at once. But that's not every student. I also highly respect the student who goes, I write everything. And sometimes I need to get out a piece of paper, extra piece of paper, and that's fine too. That's 2 to the n plus 1. That's x plus 2 to the n plus 1. That's the square root of n plus 1. Hey, Connor, okay with that? Yeah. Oh, good. So, and then I'll just divide that a sub n, which means multiply the reciprocal. It goes down here. It goes up here. We got it. And this is when this limit is always less than 1. Always less than 1. Always less than 1. Now I'm going to do the eraser thing again, so I want to copy that. And you're going to help me simplify, cancel things out. I got it easy though. I get this big green board. I could just erase things. Let's go wait. Let's save some writing. All right, I'll start with that. How can I write that? 2 to the n times up 2. I bet there's people in here who do that immediately. That's good. How can I write that? X plus 2 to the n times up. X plus 2. X plus 2. That happens every time. We got it. Whoops. And now it's time. Oh, what else cancels? Thank you. 2 to the n. So don't forget about that. The square root, this is coming out here. With bars. With bars. Now I got a limit. Because n approaches infinity. I don't have to put these bars here anymore though, because n is positive. It started at 1. So if those bars get in your way, don't let those bug you. And if you get a -1 to the end, it just turns it into 1. I didn't miss anything with my eyes, right? I'm looking over. Got that. Got the 2, that was important. And we're determining what this limit is. Less than 1. So, I hope you know this limit. Even though it has radicals, aren't those, hide that. You see what's going on? Coefficient, what is it? You are good. That is awesome. You just said that limit's 2. I mean, good on L'Hopital's rule and stuff, the derivative, but that can be a little messy. So that limit's 2. So this is interesting. This is the first time today we didn't get like the fraction. Remember we kept getting 1/2 or 1/3 or 1/4? That's a 2. So now, Connor, what would you do?
Still divide it.
He goes, that's what he does. He goes, divide 2 on both sides.
But 2 is more than 1.
But the key is, you're a step away, we're gonna find that radius. You find the radius, Katie, every time when you get this thing isolated. That's the, oh, what's the center again? X equals -2. The radius that you're talking about, that we're trying to find, will always come out to be this number on the right once you got this wiped out. Now how do you get that 2 off there? Connor said divide at 2 on both sides. So now a 1 divided 2 is what? Guess what the radius is? That's your radius. Here, the radius for this problem, 1/2. Back of book would say r equals 1/2. The book doesn't do this, I like to write this. What's the center? This is really a Professor Messenger. It's centered where? Centered at, so that means you don't have to put the center part. I just like to talk like that, so it really gives you an idea of the number line. Radius a half, where's your half radius? That's what I mean. So it's centered at x equal to what? -2. Well, let's play this out. Let's look at the interval. Hey, Katie, okay with that? All right, and we got that answer. Now, how do I take the bars off? What goes over here? So what is x between?
-2.5 and -1.
So, good job. A half minus 2 is a -1.5. What's that, -1.5?
-3/2.
All right. And then everyone subtracted 2 from a -1/2.
-5/2.
That's -2.5, -5. 98% of the problem complete. We're just going to check that number, Juliet, and that number to see if you and I can put a simple equal on either side. We haven't been able to do it yet, though. Right? Well, let's check it. All right, so I'm going to check the endpoints. I can do it here. I got enough room right here. I'm going to check the endpoints. All right, what's one of the endpoints? I'll check. How about that -5x? Now let's plug that in. I get to the nth times, what's -5 has plus a 2?
-1/2.
-1/2. Tnth over
√n.
that's square root of n?
Yep.
Well, that looks confusing to me, so I'm going to try to rewrite that. I'm checking my endpoint here, so I'm going to rewrite this. Can I put that 2 to the nth in the denominator and leave the -1 to the nth in the numerator? That's what I'll do. Because I think something cancels. Watch this. 2 to the nth there. Leave the -1 to the nth up here, and right next to that square root of n, I'll put that 2 to the nth down in the denominator. See how this was upstairs and I put that downstairs with that. So you could see what cancels. What cancels. And look at this series carefully. This is the first time this has happened today. Think of all your tests that we did in the previous week. Think of everything. Does anybody know whether or not that converges? Does that series right there converge now? I'm checking this endpoint, -5x. I get this. Does that series converge? What would be a good test with a -1 to the n? That's the hint. Alternating series test. Everyone, look at the b sub n. What's going on with the 1 over the square root of n there? That's approaching what? 0, this baby converges by AST. We get to Juliet, put an equal sign there. This gets a smiley, this works. This works. This converges by AST. Everything else today was just divergent at the endpoints. Converges by AST, look at that. Hey, this means I'm so happy I finally get to do what? I get to go like that. Cool, what's the other endpoint? I don't know if I can get both of them though. Here, maybe. Let's try the other one, what is it? I don't know if we're gonna be so lucky. What if you put a -3/2 in there?
1/2.
Oh boy, I don't think that's gonna be so nice then. 1/2 to the end?
Yep.
Uh-oh, everyone. I'll put the to the nth in the bottom. What's gonna cancel? Let me rewrite this so you can see how it cancels. That means that, right? You know what a positive 1 to the nth is always? Just 1, so ignore that, but these do what? What do you think about that series? I don't care, you can think of any test. We can't use the alternating series test. Man, you are fast. Did you know how fast they now they go? That's a P series, less than 1 diverges. Hey, cool. Everyone was saying that's a P series where the power is less than what? It's equal to 1/2, right? And then the 1/2 power, which is less than 1, that means it diverges. We can't equal that. There's your answer. That's the interval. That's a radius. If you want to put this in interval notation, how can I write that in interval notation? You can just do bracket, -5/2 and. Hey, but kind of cool. This is the first time we got the what? Got to put the closed bracket on one end. Finally! Don't let that bug you though. It's really just checking the endpoints. Don't let it be such a drag. Because what I'm saying is, look what you did. You figured out all the values of x that work. There's a lot of numbers in there. There's an infinite amount of values in that interval. You're just checking that endpoint. Okay. Hey, the last stuff we'll do today is represent a function as a power series. Oh, go ahead, Dave.
I was for the first one where you said it converges. Can you tell me exactly how it's converging?
I sure will. So it's one of our old tests. One of the tests from the previous sections. When I got down here, these canceled. I got a -1 to the n over square root of n. So I immediately thought of the alternating series test. That's what I thought of. And for the alternating series test, the term's got to decrease. 1 over square root of n, that decreases. And number 2, the limit of v sub n, that'd be the 1 over square root of n, has to equal 0. And the limit of that is equal to 0. So I go converges by alternating series test. Every one of the other ones, except for this one, we were able to say, when we looked at the endpoint, diverge by test for divergence. This was the first one though where I couldn't use test for divergence. Dave, I think it was Dave suggested, well, let's look at it as a p series, because it didn't have the -1 to the n. And the p-value right there is 1/2 less than 1. That's why this thing is actually divergent. Okay, thank you. You bet. All right, I'll write all this, get this out of the way. Function as power series.